Yeah, welcome. This is a tech conference, so now we will have some technical deep dive. That's the reason why I have to ask. So who knows what Docker is? Okay, many, but not all. Who works with Docker regularly? Oh, only few. And who does Python development inside a Docker container locally? More. That's crazy. So you're not developing on a regular basis, right? Okay. So just a few words for me. So I'm working at a company called Blue Yonder, a JDA company. So we got acquired by a company called JDA. It was founded in Karlsruhe. It's in the southern part of Germany. In one sentence, we are doing data-driven software as a service solutions for the retail industry. So we do some automated replenishment. So I started there nearly 8 years ago, and currently I'm working. We're providing more for our internal data scientists who build all these machine learning-driven applications. So that's why I have contact with things like Docker and so on. Yeah, maybe one sentence. So if you're interested in all the machine learning things and do it in a real world applications with really some data and some value outcome for customers, if you're interested to work with in such a setup, we are hiring. So just contact me afterwards. It's really interesting what we are doing. But sadly, I will not talk about anything we are doing today. Today it will be really a general purpose thing about Python and Docker. So. Funny enough, who knows this guy? It's Solomon Hykes. He's the founder of Docker. And 2013, I think it was in Santa Clara, there was a PyCon. So a similar conference like this one. And there are lightning talks, so you have 5 minutes to present something at the evening event, so everything is funny. So he showed up and says, okay, I have 5 minutes, I show you something, I don't know if you like it or not. And what he showed was essentially the first time the world has seen something, what is called now Docker. It was also called Docker back then. So he showed it in these 5 minutes. The fun thing is, so he did a live demo, and of course, I mean, if you do a live demo, so it is a really famous typo in Hello World. So he showed in 5 minutes how to put shit into containers. Even when he showed what Docker is, he showed you can do shit with it. Okay, so nice colors. A very short introduction. I cannot give you an overview of what Docker is in detail, so we want to concentrate on the things that maybe are not that good, but still, to understand the details of all the flaws we will see later on, it's important that you understand what Docker is. So maybe a virtual machine is. So a virtual machine more or less is you have a computer, and this computer simulates another computer inside the computer. So you can have computers in computers, and the virtualization goes for everything what we know as hardware, like memory, or emulates a new computer. And in this computer, you can run different operating systems. You can run those, you can run a Linux machine and a Windows machine, and so on. Docker is something in that sense. So first of all, it's tied to Linux. It only is a thing which works on Linux. And that's the following reason. So in principle, a Linux operating system is nothing else than a file tree. So you have files. For example, if I plug in this thing here in a Linux machine, it will pop up a new file. See it as a normal file, it will pop up. So on a Linux machine is a file. So a Linux operating system more or less is just a bunch of files in such a tree. Now the funny thing is, if it is like this, you can just have subtrees where you put the same structure as above and put it below here. Now the difference between an Ubuntu and a Debian, for example, is just different files in the structure. So you can have an Ubuntu running on a Debian by having this little trick which is called change root here. So you put just all files which is needed for a Ubuntu system, in a subtree, and then say to the Linux kernel, which is the thing running all the things, don't use this with all these, but you change your Debian into Ubuntu. And that's the whole idea, more or less, from a very high level view, what Docker is. So you have different things on top of it. For example, with C groups, you can limit resources to some processes. For example, you can say you are not allowed to use more than 1 gigabyte of RAM. With namespaces, you can separate or isolate processes from each other, so they cannot see each other. If you have these things, you can do what Docker is. And so I thought about how to visualize this, and this is the best thing I could come up. So more or less, you can think of, you have the Linux kernel, which is the thing which is running all the stuff, which is really figuring out, talking to hardware devices and so on. And on top, so this is more or less this spike in the middle. And now you can have different subtrees with all these files, and these are using the same pole in the middle, and you can have many of those using the same kernel. So it's using the same host file system, the same host system kernel, but with different flavors, you can call it. So, for example, compared to the virtual machine, you would have many of those poles. For every new virtual machine, you have a new kernel running with all the virtualized hardware stuff. And that's the difference. Now, yes, and I love Karlsruhe, yes, that's my favorite. So, now we learned Docker is not a virtual machine. So quite often you hear from people, Docker is just another virtual machine. That's not true. It's really something completely different on a Linux. So because if you're running, maybe questions, who uses for local development Linux? Okay, quite some. And who uses Windows or Mac? Okay, the other 50%. So if you're running on Windows or Mac, your Docker is a virtual machine because you don't have this Linux kernel. First of all, you need to have a virtual machine to run an arbitrary Linux kernel, and then on top of this Linux kernel in a virtual machine, layers of inception, you then can have your Docker system. So what Docker on Mac, for example, does, so I will concentrate on for Docker on Mac for later on because I have a Mac. I don't know how it is on Windows. And I mean, in the last month and years, Windows changed dramatically. So there is the Windows subsystem, Linux subsystem, things like this. So there will be maybe some changes, but for now it's also the same. You have a virtual machine running, and in this virtual machine you start your Docker containers. And so who has problems with Docker on Mac or on Windows? Yes, so this talk is especially for you 5. And for the rest, maybe you just listen and have fun, I don't know. So if you have problems in such a setup where you have this virtualization, most of the time the bottleneck is the mounted file system inside of this Docker virtual machine. Yeah, so that's my first tip. So if you're in a setup where you have a Windows or a Mac and you want to use Docker, then there are some tips from the ground up. So this is not specific to Python. So for example, in this virtual machine, so everyone knows what mounting means, mounting a file system. So you use your file system on your host, and then you mount it into your virtual machine. And also for Docker, it's the same. So you use the same files inside this virtualized thing. But this can be slow. And so just the normal tip is, you can configure what is mounted in the virtual machine in the first place. Also, you can, of course, you decide what volumes will be mounted inside your Docker container, which directories, and just use as less as possible. So if you mount your whole user directory, it might be very slow. Then these are some tips. So the ones who raised their hands, maybe some there are different types of guarantees you can have. So for example, if you write a file inside your Docker, the normal behavior would be the write will only come back. So the write will be finished when it's also written on the host system. So it's the same time it's written on the host file system and inside your Docker. If you don't need that because you're not interested, if it's really nanosecond, but it's completely okay if it's a second later than available on the host, then kind of thing. So try something like this. So that might speed up the things, or you can also use a completely different approach. I never tried it, but there are things like Docker sync or rsync. So you would not mount a file directory inside Docker, copy them back and forth. So you have like a rsync running, which just copies file between, so like a Dropbox. But as I said, I never tried it, but you can. So the next thing is Python. We all know what virtual env is, right? Who doesn't know what virtual env is? So we can have, yeah. So we can, if we have some Python installation, we can have some virtual environment where we say, okay, I want to install these libraries, but I only want to have it in an encapsulated, isolated thingy, so that I can just throw away this thing, the rest is untouched. Now, many people think, if I now have a Docker container, it is already isolated, right? I mean, I have one Docker container for one specific thing. So why buying and putting virtual environments inside a Docker? It's another inception. A virtual environment is also nothing else than some isolation of things, but there are reasons. So for example, it is a full operating system, such a Docker container, like a full Debian. And a full Debian comes with installations. If you try out the newest Python 3.8 features, and you install Python 3.8 inside your Docker container, there is a chance that you screw it up, and in the end you have some broken setup. So that way it is better to really use also virtual environments inside a Docker container. It's open for with this one. I use virtual env all the time and I'm happy with it, so that's why I just say that's okay. The alternative would be something like Conda. Who knows Conda? Also could be virtual environment. It's a package manager and a distribution and the environment manager. More or less, it's like a full Linux distribution in itself. That's also why I have to say even more crazy idea, because, for example, you would ship another OpenSSL version. So all these C library you would, if you take a Conda installation from your security vulnerability, it would do updates inside. If you ship it with Conda, you still have the old version running in another inception of another isolation. So you will not use the OpenSSL version from the Docker container from isolation. So, I mean, for me it feels crazy, but it just works. So many people say, okay, I use Conda and I never have problems. Fine. I mean, for me it feels crazy, but it's up to you. Now there's another tip. If you use virtual environment inside your room. So, okay, maybe one step back. We want to do local development of some, so we want to develop a library, let's say a Python library. So we want to change things. Then we have this source file. And for example, we execute using PyTest. We learned already that PyTest is the best thing to do there. We execute our tests inside the Docker container. Also put this virtual environment, so just the files inside this mounted, so because there you have many writes and many reads, and there this mounting of the volumes. So just put it in some other localization. The drawback is if you restart the container, your virtual env is gone and you have to restall it again. if it's in your mount, directly mount it again inside the container after you threw it away. There are some here. There's another tip. So pip is another tool. Who knows pip? That's good. So we use pip to install Python packages, unless maybe we use Conda, because Conda, we heard already, is a package manager. So mostly we use pip, and the drawback now, if we always start with a new container and we reinstall all our dependencies, normally pip would just go to the upstream PyPy, download everything and install everything. So afterwards you have to reinstall everything, which might take 10 minutes if it's a big thing, or 5 minutes is enough that you stand up and grab a coffee. So it's many coffees a day. So there is a tip: you can mount the pip cache. So pip will download the stuff and put it inside a cache. Would put the cache inside the Docker container. So if you throw away the Docker container and rebuild it, your cache on your host file machine and remount it afterwards. After you rebuild it that way, it will not download all the stuff again, but it uses the already downloaded cache. Is enormous, so you don't need any coffee anymore. It's a bit tricky, but I mean we cannot go into the details. Some tricks to even speed up the things a little bit more. So I already said, so normally you would reinstall your dependencies after you recreate a new Docker container. But you can also already, so as I said, the Docker image is nothing else than a whole bunch of files in a directory. So it's like a file. So there is a thing called Docker build. So you can build this file out of some build and do some stuff, and the installation to this build process. The drawback here is we will always have the same installation again and again and again. So if we need another requirement, another dependency, we have to rebuild our Docker container, which also might take 5 minutes. So again, you have to go to grab a coffee until it's finished. But but you would not have to reinstall it with every new Docker run. So it's a trade-off. If you want to drink less coffee, you can sit for information. So in a Docker would normally do a caching. So each here, and if the inputs here change, I know this already, I know this here. So just sort all your instructions you have in your build file such that the things that are changing the fastest are at the end. So if you know my requirements are always the same, but my code changes, just put this one on at last. So that's a very handy trick. So the next time you see an arbitrary Docker build instruction file, just look, is it sorted in the right way? Otherwise you can speed up dramatically. For example, if this is changing one line of code and you need to rebuild, this would. So a very handy trick. Now, everything we heard so far was really just general Docker hacks. But now let's put the Python in the box. So we want to do real Python development inside a container. So there comes a first decision we have to make. Who knows Docker Compose? That's good. So I googled a lot for egg crate 1 egg to take a photo for myself. So sorry, that's a really bad photo, but that's from my mobile, so it's a shame. But okay, so the picture is for this. So a short wrap up what Docker Compose is. So normally we talked about creating one container and doing something, but a real world application often consists of different services like a database and a web server. So in the Docker world, you would start one container for your database and one container for your web server. Now, how to orchestrate the whole thing? Docker Compose. So Docker Compose would take would take everything from you to, for example, do the networking between the containers. So many people would say, if I don't need more than one container, I don't need Docker Compose. But that's not fully correct. I mean, it's a little bit abusing the whole thing, but there is something interesting in this Docker Compose. You have this Docker, which is a declarative description of how your Docker setup should look like in the end. So this is where you say, I want to have a connection between my database and my web server, and maybe some Nginx or whatever. And this is quite handy because it is a declarative description. For example, which mounts do I want to have, which networking, maybe I want to forward some ports and so on. Some environmental variables, things like this. So all the configuration stuff. The thing is, we don't need all possible inside as a normal Docker command, so where I just have command line options, but we can just write such a nice declarative style, put it in our Git, so we can share how our local setup looks like in a very nice way. So it's an advice for me. So if you want to work streamlined local development workflow, which you can also share with colleagues, for example, over Git, then this is a very handy way. Who knows what this is? Yes, it's a fig. Fun fact, Docker Compose was formerly known fig, and it's purely written in Python. So all the Python developers, just have a look. If you dig down very, very, very early, maybe 2014 or 15 or something, you will find a commit from me, maybe. So nowadays it's called Docker Compose, but it was a completely separated open source project, everything written in Python. Nice way to just get a feeling what is on, because we all know Python, so we feel very home here. Docker is written in Go. Naja. Okay, next problem. So how many minutes? I have to speed up. So pip install edit. So just to give you an impression of the whole problem. So this is from the GitHub issues page. So many screenshots. So this is the issue concerning the pip install -- editable flag. You use it inside a Docker container. Still open, I think it's from 2014 or something. So we cannot solve the whole thing. It's a bit a shame. So just to give you a very short introduction what it is about. So pip install -- editable means we don't install the package inside some environment, but we use the local tree and just do a link, more or less. So if we change one line in our source code, we don't have to reinstall it and then do the use it. For example, if we import it, but it is directly what we changed is directly used. This means -- editable. Python packaging is really a mess. Pip install editable will always place an info inside the root of your working directory. No, not the working, of the root of the source tree, of the package source tree. But this is the one we want to mount inside the container. And we have to do the pip install inside the container. So we have two options. Either we install it beforehand in the build step. If we then remount our whole directory, all of a sudden this file vanishes because it's not on our host file list. It gets installed. So either we have, because all of a sudden this link is missing, so some operations will fail
but still you can have these issues, so sometimes it just nukes. But no problem, we have Stack Overflow, so that's the solution. So Python says, yes, we want to develop in Docker. Yes, we have a problem, so here's the solution. All you need to do now, so if you go home now, all you need to remember from this day is just learn by heart this command here, then go back home, do an alias in your terminal, and your life is saved. Yes, so some final remarks. I have a snowflake here. So the reason why Docker took off was the idea, instead of having everywhere different environments, we ship the environment with these files. So we just package everything more or less in a zip file, and then we can ship those files around from our laptop to our Jenkins setup into production, so that we have everywhere the same setup. Now, everything I showed you before will only be done in your local setup. So more or less we are screwing up the whole idea of Docker, because what we want to have is the same environment like it's later on running in production. Now, we did all these fuckeries with Python path, we did delete some files, we mounted different things. So this is just a warning from my side. So if we take this to the top, we will lose the whole idea of Docker. Once again, we will have problems where my tests get executed very nicely in my local setup, but will crash in production. So this is just a warning from my side. And so I think the very sad thing about the whole stuff is the whole Docker setup will be the first contact with users of any Python library or Python framework or Python application or whatever. So normally you go to GitHub, maybe you read some Hacker News, then you have there's a new deep learning framework. You go on the GitHub page, and the first entry point will be, where is the Docker setup? Okay, here. And what I showed you before holds for every project in Python. So it's really, Python is not ready for this whole world, I would say. So there are these fuckeries we cannot overcome. So more or less this looks like the entrance to every Python project. And that's a problem, right? I mean, shouldn't it be like that? It should be like, wow, awesome. I just type Docker compose up and everything is nice and shiny, and if I want to create a new project, it's just like bam, and everything is seamless and working fine. Yeah, it's not. So this is the final outlook. So what are our options here? So we can just say everything is fine like it is today. But so I think the biggest reason why I made the whole talk in the first place was awareness. So when I started to dig deeper into this, because I wanted to have I wanted to build this for some of my projects, and I was like, what the fuck? I must be the most stupidest developers in the world, because I don't get it like this. All I get is this. So it must be me. Until I realized by reading all those blog posts, Stack Overflow and so on. So I finally realized, no, it's not me. It's really the whole Python setup. It has a problem there. And we saw the GitHub issue page, open issue since 2014. We cannot decide on these things. So there is a problem. And so first, so what you take home, probably it's not you. Maybe Python has a problem. So don't cry. Don't be ashamed. Maybe it's not you. The other thing, of course, is we have to somehow contribute. Yes, the issue already is very, very, very long. But I mean, we cannot just say, okay, the thread is already long, so we cannot chime in. I think we all have some responsibility to chime in and say, no, that's not the state we want to have. We need to change it. I mean, at least a suboptimal solution would be better than having no solution at all, like in some cases we have today. Sharing, I mean, that's the reason why I give this talk. So if you encounter one of these quirks and you find out probably it's not you, write a blog post, give a talk at a PyCon. It helps a lot. So it helped me a lot to find these blog posts and seeing talks where such things are made aware. Then, I mean, we have the Zen of Python. I hope you all know it. And then there's this one thing, there should be only one obvious way to do it. And that's clearly not the case. There is no obvious way to get that right. And code, I mean, some of the works, there is a possibility we can somehow cover it up with some tooling. I mean, what I did just in preparation for this talk, just to try to reproduce some of the quirks, if it's really me or if it's a setup. So I started something called the Dockerized Python scaffold. So just for me, what is the most basic setup which we can come up, which is more or less same. So which, I mean, it still has these quirks and workarounds inside, but at least the workarounds are somewhere hidden in there. So I would be really happy if people go there or start their own maybe blog post, and then maybe we can start to build some toolings around it so that the situation is better afterwards. So I think this is the best closing for this one. Thank you.
Great, guys. We have 5 minutes for questions. The first hand over there, and then I'll go back to you.
Thank you for your presentation. My personal pain about Docker and Mac, it's not only Python, but maybe you came across such problem. It's bypassing localhost from the container to Mac localhost. So sometimes we need to use localhost in Docker environment inside Mac, and as you mentioned, it's virtual machine, and we need to use localhost in your local Mac environment. How could it be solved?
So, I mean, there's the problem I have every day. I'm in the platform team working with all those infrastructure folks, and so I'm a data scientist. I have no clue what a socket is, and so I cannot answer your question. But I mean, as I said in the end here, I mean, there is quite some material out there. So there are many blog posts. There are people who understand this much better than me. So try to Google it. If you don't find the best thing, try to figure it out and write a blog post. Then you can share your knowledge with everyone.
Thank you for the presentation. I have a question related to the thing that you said, that the Docker is using the host machine's kernel, right? And if I have on my dev machine, for example, Debian, but on the server I have a CentOS, does this mean that environment would be slightly different, and would it cause a different behavior of my application, the dev environment and the production one?
So you mean you would develop inside a Docker container or on your... So let's say your local host machine is a Debian.
Yes.
Would you then develop on Debian or inside a...
I have a Debian on the local machine, but on the production server I have a CentOS.
Then I would create a CentOS Docker image and do the same thing. And I mean, that's why we built Docker in the first place. You want to develop on an environment which is as close to production as possible. Exactly. And Debian and CentOS are different things. So you have no guarantee that things you are testing on your Debian will not crash in. It might well be that in 99% of the cases it's okay, because both are Linux. I mean, it would not be okay to do your tests on Windows and then run it on a Linux. There are so many differences, so I would never trust such a thing. So
if I have an image with the CentOS, it's running on my local Debian. Will it be a kind of virtual machine or not?
No, then it's not a virtual machine at all. And really, I mean, spinning up on a pure native Linux Docker container is something like I think 200 milliseconds. So it's really instantaneously it's there. And many of the problems with slow mounts and so you also don't have, because there is not this virtual machine in between. So I think it totally makes sense, and it's really nothing new. So change roots are around since, I don't know, 20 years at least, and people used it also back then. So it's really just you want to have a new file system, and it's really nothing more than this single command change root. So you just say it's use this file system here. So there's no problem running Docker containers on a Linux. On the contrary, it's built for that. So
Thank you.
Okay, any other questions? Okay.
Can you explain in a few words how Docker works with Linux kernel on Debian, for example, on the lowest level?
Yeah, I mean that's what I tried to show you on this slide here. So in principle, it's really this. So this is a file system. So you really have your root directory. Then it's also on a Mac, or I mean on Windows you also have these files lying around. But on Linux it's much more compressed because they look quite similar in all different distributions. So like Linux and Ubuntu, they are different, but more or less you see all these bin and user and local share and so on. And then it's really just the whole tree of files defines what the operating system is. So having just a subtree of the same files means it's the same operating system. So Linux distribution or whatever, maybe that's not the right word to use, I don't know, maybe it is.